West Virginia. I am ready to swim into math. So how about joke of the day, because it is the best part of the day. Have you ever tried to eat a clock? Well, it's really time consuming. So let's not waste any more time and let's get into odds. Odds is an offshoot of probability, and we've already defined probability. We said the definition of probability was that it was successes over totals. So let me get that definition up here one more time. The probability of an event is going to be the number of successes over the total. Because we will use this formula for probability, or definition of probability, to talk about odds and to generate the formula for odds. Now we can have odds against an event and we can have odds for an event. And depending on whether you're dealing with odds against or odds for, you'll take one formula and basically you'll flip it around. Because you'll notice in both of these cases, I am no longer talking about total anymore. Now I'm talking about failures and successes. Successes should be familiar because that's part of the definition or the formula for probability. However, we're no longer talking about total, we're talking about failures. So if I want to talk about, let's skip down here, the odds for an event. If it's for something, that means it's good. That means I want it to happen. That means a success. So the odds for an event will no longer be successes over total, but it'll be the number of successes over the number of failures. But on the flip side, if I'm talking about odds against an event, against is bad. I don't want it to happen. So that means a failure is what I'm looking at. So it would take this formula for odds for an event and it would flip it so that it would be the number of failures over the number of successes. Now in either of these formulas, I can look at, if I don't know the number of successes or the number of failures, or for that matter, the number in the total, and all I know is the probability of the event or the probability of a success, the probability of a failure, then I can use those probabilities to come up with these odds. So in other words, if I'm looking at the odds against an event and I don't know the number in the total or the number in the failure or the number in the success, I could say I'm still concerned with failure, but instead what I'll do is the probability of the failure over the probability of the success. Flipping that around, if I'm talking about the odds for an event, then what I'm going to do is I'm going to say, if I don't know those numbers, but I know probabilities, then I'll say the probability of the success of the event, because I'm looking for 4. That means good. That means I want this to happen. So I'll do the probability of the success over the probability of the failure. So let's take a look at an example here. And in this example, we've got the names of 12 girls and 18 boys. They are written on slips of paper, and they are placed in a hat. And then we're going to draw one name at random. And so what we want to do in the first case, and I cannot see anymore, so let me get this off here. So what we want to do in this first case is we want to know what's the probability that it is a girl's name that's drawn. Remembering that this formula for probability said that it's going to be the number of successes over total. So I need to figure out, okay, how many successful ways can I draw a girl's name? Well, there were 12 girls' names put in the hat. So that probability that I'm getting a girl's name will be 12 successes, and now I need my total. How many total names are in that hat? Well, remember, I've got 12 girls and 18 boys. 12 plus 18 will give me 30 total names in that hat. So I have 12 out of 30 as my probability of that event happening. You always simplify a fraction if you can. 12 over 30 does simplify because 6 will go into each of those numbers. 6 goes into 12 twice. 6 goes into 35 times. So here's the probability that I will select a girl's name out of that hat. Now, let's talk odds. So if I want to know, all right, if that's the case, what are the odds against drawing a girl's name or against the name that I pull out being a girl's name? The odds against. So if I'm looking odds against, then I'm concerned with failures. So odds against then, odds against would be number of failures over the number of successes. So how many ways can we fail at drawing a girl's name? Well, there's 18 boys' names. That's how many ways we can fail at drawing a girl's name. So it would be 18 failures But how many ways can we be successful at drawing a girl's name? There's 12 ways to do that, so it would be 18 over 12. And once again, always simplify a fraction if you can. 6 will go into both yet again. 6 goes into 18 3 times, and 6 goes into 12 2 times. So my odds against would be 3 out of 2. Now when you deal with odds, sometimes you write it as a fraction, but sometimes you write it as, say for instance with this 3 out of 2, I can write it as 3 out of 2, or I can write it as 3 colon 2, or I can write it as 3 2 2, the word T-O. These are the 3 different ways that you can write odds. Now that was odds against the event. Oh shoot, that would go up here. Apologize. 3 to 2, 3 colon 2, or 3, the word 2 to 2. Now let's talk about odds for in that case. So if the odds against would be 3 to 2, then odds for, remember, all that does is it takes this and it flips it because we want successes over failures. So if I want odds for drawing a girl's name, then I would have the number of successes being 12, number of failures being 18. Once again, always simplify a fraction if you can. 6 still goes into both of those. It goes into 12 twice and into 18 3 times. So here's my odds for, which I can write it as this fraction, or I can write it as 2 colon 3, or I can write it as 2 2 3. Any of those 3 ways is perfectly fine for expressing odds. So let's take a look at another situation dealing with odds. And so this time, oh dear, the under the sea is getting crazy here. So this time, let's take a look at a situation where we've got a bag, and that bag contains blue marbles and red marbles. And so in that bag that contains blue marbles and red marbles, based on the number of marbles of each type that's in the bag, and I don't know how many marbles are in the bag, but what I do know is based on that makeup, the probability of choosing a blue marble is 0.40. In other words, 40% of the time I can choose a blue marble. So knowing that information, I want to come up with a couple of scenarios, and I want to say, all right, what are the odds against choosing a blue marble? Now recall that when we're talking about odds against would be the number of failures divided by the number of successes. The problem here is that I don't know how many failures and how many successes I have. So another way that I can express is that I can say, well, I'm now going to talk about the probability of a failure versus the probability of a success. Well, I still don't know the probability of a failure, and I don't know the probability of a success. Well, I do know the probability of a success. It is 40% of the time I can choose a blue marble. So I do know that in that denominator, I've got 0.40. I need to know the probability of a failure then. If success is 0.40, then failure would have to be 0.60, because total probability is going to be 1, and 1 minus 0.40, because remember we talked about a certain event being 100% of the time, or a 1. So I'm going to take that 100% of the time, I'm going to take out the probability of my successes, and that will leave me with the probability of my failures being 0.60. So that means my probability of failures is 0.60, my probability of successes is 0.40, but I'm going to simplify that fraction. Now what I definitely need to do is take that, I can drop off the zeros, and I can get a 0.6 divided by a 0.4. And then for that matter, if I just multiply both by a 10, numerator and denominator by the same number, 10 divided by 10, for that matter, I could have done that right here. I could have multiplied the numerator by 100 and the denominator by 100. And that would have given me 60 over 40 and drop the zeros. Or I could multiply by a 10 and a 10, giving me 0.6 and 0.4. Either way, I'm going to end up with a 6 over 4, which does reduce because 2 goes into both. 2 goes into 6 3 times, 2 goes into 4 twice. So that is my odds against, 3 to 2. Or as I said before, I can express it this way. I can express it as 3 colon 2, or I can express it as 3 2 2. And that is my odds against. Now, another way that I can look at this is I can say, well, if I know that the probability is 0.40, here's another option. Recall the probability of an event is going to be successes over total. And again, I don't know each one of those, but what I do know is that 0.40 is the same thing as 4/10. And 4/10 simplifies to 2/5. So what that tells me is my successes is 2, my total is 5. So if I have 2 successes and 5 total, then that means my failures, if I take 5 and subtract 2, my failures is 3. So going by this definition right here for odds, number of failures over number of successes, I found out that my failures is 3, my successes is 2. So it would be 3 to 2, which is exactly what I had right here. So either of those options is perfectly fine for figuring out your odds against. If you know that probability, you can convert probability into that formula and simplify your fraction so that you know how many is in your success and how many is in your total. Now using that, we can look at this question that says, okay, what are the odds for? Once again, if I have calculated odds against, all I have to do is take this and flip it for odds for. Because odds for, recall, is going to be the number of successes over the number of failures. And we just figured out that a couple of ways of doing it. One is to say that I figured out 2 successes, 3 failures, so I've got 2 to 3, which can be written as 2:3 or 2 to 3. Any of those is perfectly fine. But if I want to go with this idea of these percentages, then with the percentages, it would be the percent of successes over the percent of failures. And like we said before, the success I was given is 0.40. Failure I figured out because it's 100% minus 40% is 60%. And like we said before, I can multiply this by 10. When I multiply it by 10, I get 4/6. And like we said before, simplify a fraction if you can. 2 goes into both of those. 2 goes into 4 twice. 2 goes into 6 3 times. And I get the very same odds against. So hopefully this helps you to understand odds. Again, basic definition is what gets you through here. Basic definition is odds against. That focuses on a failure. So I want the number of failures over number of successes, or the probability of failure over probability of success. Odds for focuses on something that's good, something I want to happen. So it focuses on successes. I want the number of successes over the number of failures. Or again, probability of success over probability of failure. And understand that these two, in comparison to basic probability deals with successes over total. But all 3 of these can work together. And I hope that helps. Have a great day.